Hi guys, let us look at another example here where we have to find the trig ratios. Guys, in this case we have given that the sine of the theta, sine of an angle theta is 4/5, and based on this information we have to find the other 5 trig ratios. Guys, it is not too complicated. All we have to start with is we have to first start by drawing a triangle, a right triangle for our reference. And the other thing that we have to keep in mind here is that the angle, any of these angles that we work with are going to be acute angles. Okay, so first thing I'm going to do is I'm going to draw a right triangle. So let me draw a right triangle, and it's up to you which one you want to call as your reference angle. Guys, I'm going to call this angle as my reference angle, and here the reference angle will be denoted by theta. So based on this information and knowing the fact that the sine of the reference angle is the opposite over hypotenuse, so guys, we can say that the opposite here, which is this side, is 4, and the hypotenuse, which is the longest side of any right triangle, is 5. So it is more like that the opposite over hypotenuse is in the ratio 4/5, rather than just exactly saying that it's 4 and 5. But guys, for calculation purposes, just setting it equal to 4 and 5 is going to serve the purpose here. Okay, so once we have identified the opposite and hypotenuse, guys, in many ways it becomes similar to the problem that we did previously, which was example number 1, where we have a right triangle, we have 2 of the sides, then we find the third missing side, and then from there we write all the other trig ratios. So from here, guys, obviously we need to first figure out the length of this side, which here is going to be the adjacent. To find that, guys, we are going to use the Pythagorean theorem. So from Pythagorean theorem we have to do 5 square minus 4 square, and that is going to be the length of the third side adjacent square. So this is 25 minus 16 is a square, and when I simplify I get a square equals to, so it is 9, right? And then when we take the square root on both sides, we get the length a equals to 3. So this is the length of the adjacent, which is 3. So guys, some of you probably, if you have already seen these type of things in geometry, you may remember that this is like a 3, 4, 5 triangle. These are some special triangles which form right angle triangles. So this is one of those 3, 4, 5 triangles. Okay, so guys, I have the lengths for all the 3 sides. We already have the sine of the theta. We have one of the trig ratios. We have to write the other 5. So let us start with writing the first. I'm going to write the cosecant, the reciprocal of the sine. So cosecant is the reciprocal of the sine, which is same as saying it is the hypotenuse over the opposite. So that's going to be just simply 5/4, right? I just reciprocated it. Second one I'm going to find is the cosine of theta. Guys, cosine we know is the adjacent over hypotenuse. It helps if we have this already written out on our notebooks or wherever we are actually working on it. Okay, once you are like good at it, guys, then it's up to you whether you want to keep on writing this short form or not. It's up to you. But initially, guys, if you're just starting to do these examples, then one should have that short form in front of us. Okay, adjacent over hypotenuse, adjacent is 3 and hypotenuse is still 5. Then let us find the reciprocal of the cosine, which is just the opposite or reciprocal of this. That's going to be 5/3. Guys, the fourth one I'm going to find here is the tangent. Tangent we know is the opposite over adjacent. So opposite is 4 and adjacent is 3. Guys, at the same time, let me remind everyone that the tangent is also the ratio of the sine over cosine. So let us also verify that if I take the ratio of the sine over cosine, I would still get 4/3. So sine is 4/5, and then what is my cosine? Cosine is 3/5. Guys, if I simplify this, it's going to look like this: 4/5 times 5/3. Right? When we change this division to a multiplication, we have to reciprocate this. So it becomes times 5/3. What happens right here? 5 and 5 crosses, we get 4/3, and that's exactly what we got just by using this simple opposite over adjacent identity. Okay, so guys, you should use the easiest possible way of doing things, but sometimes if there's, you should also know there are other ways of finding things. Okay, so keep this in mind as well, that the tangent is the ratio of the sine over cosine. Then the last one is the cotangent, which is the reciprocal of the tangent, and reciprocal of this would be just simply 3/4. So guys, that's how you would actually find the trig ratios given one of the trig ratios. Just you start by drawing the right triangle, find the missing sides, and then go from there. Okay, nothing complicated. Guys, I'm still going to show you many different types of examples in this section. Keep practicing them, and I will see you in the next video.